Good. Graph the solution set of the following system of inequalities. So y greater than or equal to x squared minus 9 and x minus y greater than or equal to negative 3. Perfect. So I'll find the points of intersection. Actually, let's write first of all x squared minus 9, which we know by transformations, x squared minus 9. And the intersects here are negative 3 and 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So solid, yes. Make it as symmetric as possible. It's not possible to be perfect. As you see, I'm not getting what I wanted to get. Let's see, this is a little bit better. It has to be symmetric with respect to the axis of symmetry, which is the y-axis in this case. Good. So it's solid because the equal symbol is there. I only graphed the equation. What equation? Y equals x squared minus 9. I see that this equation divides the plane into two regions, inner and outer. I'm checking the inner with the easiest point ever, 0, 0. Is 0 greater than or equal to negative 9? Yes, it is. What is the inside? This inside is y greater than or equal to x squared minus 9. Now I look at the second equation. When x is 0, y is 1. 0, 1. When y is 0, x is negative 3. So negative 3, 0. So I graph negative 3, 0, and 0, 1. Solid, yes. So y minus x equals, oops, negative 3. Good. This line divides the entire plane into two regions, above and below. The below contains the origin. I am going to use it. 0 greater than or equal to negative 3. Yes, that's true. It's true. So this is y, x minus y greater than or equal to negative 3. Now we are intersecting the inner with the green or whatever this color is. So everything points on the curve and everything in between. What is this? Both. Both at the same time, meaning the solution of the system. Any questions on this problem? Good. Anything else? Is there anything else we want to go over? Anyone? Anyone else needs help with anything? Are we continuing to review for test 5 or are we done? Emily Imani Hunter, what would you like to do next? Please.
We can continue working on test 5. I just want to make sure I have everything absolutely correct before we do that.
I'm ready. Anything.
we do some word problems?
Yes. Okay. Very good. So here's one. I think we did these problems, didn't we? Let's look at the equilibrium price. Equilibrium point, I meant to say. Okay, so here's an example. The bar graph indicates that fewer US adults are getting married. So the blue is going up, as you see over the years. It has been gone up, never married, and the number of people who get married decreases. Okay, so they're giving us two functions, actually two equations. The data can be modeled by the following system of linear equations. Use these models to determine the year, rounded to the nearest year, when the percentage of never married adults will be the same as the percentage of married adults. For that year, approximately, what percentage of Americans, rounded to the nearest percent, will belong to each group? Okay? So any suggestions on how to address this? So we have a system, and the system is negative 3x plus 10y equals 160. And this is again problem 67 on 559. Okay. And the other equation is x plus 2y equals 142. So how will you find basically the point of intersection? As you see, this one is a linear function with a negative slope. This one is a linear function with a positive slope. So how will I get the point of intersection? What do I need to do? And which method would you like to use?
We use substitution.
Sure. Sure. And we
So we
substitute.
solve for x.
Very good. Negative 2y plus 142. And I replace it in here by negative 2y plus 142. Careful, because I have a negative 3, and I have to make sure that I distribute it to both terms. So negative 3 quantity, negative 2y plus 142 plus 10y equals 160. Okay, I distribute 6y minus 6 and 42 and plus 10y equals 160. 10y plus 6y is 16y. I move this to the other side. 426 plus 160 is 536. And I'll see what I get when I divide 536 by 16. Good, 33.5. So now I have to find x. So x is negative 2 times 33.5 plus 142. So times negative 2 plus 142. Okay, I got 75. So I claim that the ordered pair is 75 comma 33.5. Is it? I don't know. But it's very easy to check. 75, 75, 33.5, 33.5. So 75 plus 2 times 33.5, do I get That's not what I meant. So 75 times 2, and that insert yes. So I got 142, that's correct. Now, negative 3 times 75 plus 335, because I multiply by 10, do I get I did something. So let's see what I did.
$426 plus 160 is
Yeah.
586.
Yep. Got it. I was just looking at it. So 586 divided by 16. It's 36 point. So y equals 36.625. So then in that case I'm just going to do this. Sorry about that. No intention. Okay, so now x is negative 2 times the previous answer. Okay, didn't like anything right now. Okay, so I have negative 2 times this, 36.625, and plus 142, 69.35. So we claim 69.35, comma, 36.625. Is it true? I have no clue. That's why we should always check. 69.35. I'm just going to erase these and start from scratch the checking part. This I can do quickly. What if one day we run out of whiteout? What will I do then? I'm kidding. Okay, so I have to check. Negative 3 times 69.35 plus 10 times 36.625. It has to be 160. If it isn't, wrong. So then x 69.35 plus 2 times 36.625. If I don't get 142, the solution is incorrect. I have to go back to the drawing board. 69.35 plus 366.25. Wow.
I went back and did it again, and I got the x equals 68.75, and when I checked it, it was correct.
But it means that this is incorrect still. 586. So the y, 5, oh, so 586 divided by 16, that part is correct. Okay, and now I'm checking this. So times negative 2 and plus 142. So, and how did I get this? Never mind. So I have to start from scratch. Okay, one more time. Negative 3, negative 2y plus 142 plus 10y equals 160. So 6y minus, this is still 426, plus 10y equals 160. So this is 16y, and this is indeed 586. So then y is indeed 36.625. Is this okay?
Yes.
Okay, now I have to find x. So negative 2 times 36.625 plus 142. So, is my calculator acting up or what is going on here? Negative 2 times 36.625, yes, plus 142. Okay, so indeed this is 68.75. Okay, maybe now, who knows? Okay, third time is a charm. And again, 36.625. I still have to check. I trust you, but let me check. I'll feel better if I check. Okay, so we have negative 3 times x 68.75 plus 10 times 36.625. Do I get 160? Finally. Thank you. Okay, so now 68.75 plus twice this, 36.625. Okay, 142. Finally. Okay, good. So now we have to explain what the answer means. So we go back, we look at the measurement units again. So the measurement unit is year, but the year starting from 1970. So 10 and 10 and 10 and 18. So they're not expecting us to have, in order to determine the year rounded to the nearest year, when the percentage of never married adults will be the same as the percentage. So the x is the year and the y is the percentage. Okay, so the percentage, when that happens, will be approximately 37%. That's the y, percentage. So they both will be 70%. And this makes no sense. This is not the year. This is 68 years after a year. So this is, the problem is not complete. So 68 years after 1970. Although it doesn't say, but it makes no sense. X years after 1970. Okay, they put it in the voice balloon. Okay, fine. So it's 68, or it's roughly 69 years after 1970. Now it makes sense. I agree. So this represents 1970 plus approximately 69 years. That's when it's anticipated, if the model still holds. We don't know that. But 36.6% of, so 69 years after 1970, the percentage of married and unmarried will be equal at roughly approximately 37%. Any questions? So when we add this, what do we get? 2039 approximately. So the year in which those who are married and those who are not married will equal each other will be at 37%, will be in the year 2039, assuming the model still holds. That we don't know. It's too far out to tell. But if it does, that's what's going to happen. Good. Next question.